Hello, everyone, and welcome to this quick little lecture. And we're going to be talking intro to containers in this one. We're going to talk about what containers are, why they're even a thing, and then also what advantages that they bring to us. We're going to do some demos, and I totally recognize that, especially those of you that are new to containers, it may blow your socks off a little bit, and they're because they are pretty awesome. And hopefully, this will provide at least just a little bit of foundational understanding of what containers are, what problems they're trying to solve. Of course, you're not going to become an expert by the end of this little lecture here, but hopefully it'll again give us some foundation for when we start talking about Kubernetes, etc. So, talking containers and just computing in general, we've been through a lot of transitions over time. We started off with when machines were huge and expensive, and there was only one machine that an entire company or the entire university would use, and you'd have to wait in line in order to run your jobs. Well, over time, machines started getting much smaller, and then you can just run one on your computer. And so, we had servers, and these servers, we could install software on them, we can run applications, etc. And now more people can do more things with that. Over time, we figured out how to even take those servers and kind of carve them up into smaller machines, and that's where virtual machines and hypervisors come in. And that's what, for example, allows you to run like VirtualBox on your machine, and you can run lots of VMs on your machine. It's the same technology. So again, it's this idea to be able to take a single machine and then carve it up into lots of smaller pieces. And in many ways, we're going through a very similar transition right now as well. But in order to understand it, I'm going to kind of go back in history a little bit, and we're going to use an analogy. So a long, long time ago, most shipping was done by land and sea. Okay. And if you were a goods maker, you had to package up your goods in whatever it was that you can find, whether barrels or crates or bags or, whatever that you could use. You shove all your stuff in there, you take it down to the dock, you give it to a shipping vendor, and they would pack it into the ship as much as they could, and then they would go out to sea, and then they'd have to unpack everything for the things that were getting off at that dock. So get everything off the ship, leave the things that are supposed to stay there, then pack it back up and go on to the next port. And so ships actually spent more time at dock loading and unloading their cargo than they did actually out to sea. And the chance of loss or theft was extremely high because, well, everything is being touched multiple times, and if I were a untrustworthy docksman, I could, oops, I slipped this bag, and now I'm pocketing some of the goods that were in there, and it happened quite often. Well, when the Industrial Revolution came, rail now sped up the process quite a bit, and now we can move things across the land much faster. And every time that we get to a rail station, now you're moving goods from one car to another, and so we had the same problem as before, but now we're running into it much more frequently, as we're wanting to go from sea to car to another car to another train line, etc. Maybe out to sea again, and it really just made the inadequacies of this load and unload process. It just made it really, really apparent, and so a better shipping practice was needed. And so somebody had the idea of like, why don't we just standardize around a box? And if we standardize around a box, then me as a shipping vendor, I can just say, hey, goods producer, put whatever you want in this box. And then me as a shipping vendor, I don't have to care what's in the box, but I can standardize around the box, and I can move my goods around. I can move all the boxes around. I know that it's going to be a certain dimension, and I can lift that box up with cranes, and I can put it onto a truck chassis that recognizes that's designed for that size. And then I can move the goods around as I would expect. And again, I don't have to care about what's in it. And now goods are being able to be shipped around much, much more efficiently, and the chance of loss or theft absolutely plummeted. And now we see, shipping yards just like this, where there's lots and lots of containers everywhere, and things can go from land to sea to car or to rail, and trucks across the highway and everything, and it's much, much more efficient. So now the question is, how is software like shipping? It's actually very, very, very similar. We ship software around. We build software, and in the past, deploying software was pretty painful. Remember, well, okay, it's probably before most of you were aware, but A long time ago, especially before the internet, you'd have to burn either discs or CDs and then put them into a store, and people would have to go get them. And so you had to really make sure your software worked because, well, you can't send a patch. You'd have to burn new CDs and distribute it and all that kind of stuff. It was really painful. The internet has definitely changed things because now we can ship patches much faster, but it's still painful, and we still have to be careful on how we move our software around, and especially if you're setting up servers. Well, if I need to add capacity to an application, well, great, let's set up another server, let's install all the software, um, get all the right versions of stuff. That's a lengthy process, and especially now in today's day and age where we're wanting to adapt to users' needs as quickly as possible, um, we want that process to be as quickly as possible. So, and much like the Industrial Revolution, we were starting to notice these pain points of like, it takes a lot of time to set up a server. And how do I know that the local development environment is the same as the production environment? And, and yeah, these inadequacies just became really, really clear. So somebody thought of, why don't we change how we do things? Okay. And so what's happening over right now is that this abstraction layer is rising, in which we no longer install stuff directly on the server. We use containers. Okay. And I recognize that, again, most of you may not have done a whole lot with VMs. Let me grab the laser pointer here. Boop. Okay. So if I've got the infrastructure, the bare metal, there's a host operating system and a hypervisor, and I can spin up multiple guest OSs. So if I want to run an application that maybe has 3 different versions, um, I would spin up 3 different guest OSs. And that's a lot of overhead that I'm having to spin up a new kernel with its memory management and schedulers and everything that just comes with the kernel just to run an application. And what containers allow us to do is I can bundle everything that an app needs to run in a standardized format, and they can run in isolation, but yet still share the same kernel. Okay, and I know this, if you don't understand like that layer of computing, it may not quite make sense, but hopefully it'll make sense once we do a demo here in a minute. But so on the same machine, I can run all 3 apps together, and they can run side by side, and I can share the machine, so I can pack more into it. But again, as a kind of going back to the shipping vendor, if I have this container, it's a standardized packaging structure that allows me to pack whatever I want in it in order to run an application. So app 1 may be a PHP app 2 may be a Java app 3 may be a Node.js app, or they may all be the same stack but different versions of things. And I can pack this container and just run it on the machine. And as myself as a machine operator, I don't have to really understand how it works. Just like the shipping vendor doesn't have to know what's in the box. Okay, and again, this will make more sense as you get more experience with it and as we go throughout the semester. But so what actually is a container? Let's define that. Simply put, a container is an isolated process on the machine, nothing more. So if anybody does tell you a container is a virtual machine, tell them they're wrong. And you can tell them that Michael Irwin said that. Okay. A container is just an isolated process on the machine, and it leverages a kernel feature that's called namespaces. And what namespaces do is they can change the view of the world that a process has. So for example, inside of a container, it can only see its process and all of the processes it spawned, all of its children processes, but it can't see any other processes on the machine. And so this is leveraging namespaces to change its view of the world. So if I'm running inside of a container, since it's using its own process namespace, it can't see another container running on the same machine or any of the host processes on the machine. But at the end of the day, it's still just a process on the machine. So if you're on the host, you can see all the processes, all the containers. And there's similar ones for file system, user groups, etc. Maybe we'll do a demo of that here in just a little bit. And when a container runs, it uses what's called a container image to provide the file system for it. And that file system contains everything that needs to run the app. All the binaries, all the configuration, all the source code, any libraries, basically everything that needs to run that app. And the idea there being, again, going back to shipping, if I have this container image that contains everything to run an app, I can run it on my local machine or on a production server or on my colleague's machine, whatever, and it's going to work the exact same everywhere. And that's pretty powerful. Okay, so let's do a demo here. What I'm going to do is I'm actually going to create a project, and we're just going to do this live here. Okay, so I'm going to pull up Visual Studio Code, and I just have an empty directory here, and I'm going to do a Node project, and we'll just kind of go from there. So I'm going to do a yarn init, and if you don't understand any of this, don't worry, that's fine. Yarn add express. So I'm going to just add express, which is an HTTP server. And what I'm going to do is, let's make a source directory, index.js, and I'm just going to write a really simple app here. Oops. Okay. So app on, let's say on the root, we're going to get the request and response. And I'm going to send a JSON object, a message, hello. Okay. And now I just need to listen, and we'll listen on port 3000. And we'll just log a console log message, listening on port 3000. Hooray. Okay. So now I can run this locally. So let's do a node source index.js. Okay, and now if I get another terminal here, and if I curl localhost 3000, I'll go verbose, I should see, oops, I did that wrong. Okay, my bad. Okay, there's no, I have to do app.get. Okay, and so I get my little JSON object message hello. So if I were like building a whole like API endpoint and everything, I can send objects of like users or to-do list items or whatever it is that I want to do here. So really basic. Now, if I wanted to package this up and send it to somebody, I could create a Docker file. Okay, and I'm going to do a what we're going to do is I need to specify the base image that I'm going to use. And again, I'm not going to get into all the different things that that I need in order to actually build. We're not going to get into layers and all the different mechanisms of what we need here. But what I'm going to do is I'm just going to do a node Alpine. All these pop-ups from Visual Studio get a little in the way, huh? And I'm going to set a worker app, and I'm going to copy package.json yarn lock in here, and then I'm going to run yarn install and yarn cache clean, and then I'm going to copy my source directory into the container, and then I'm going to set the default command that when I run this container, it's going to run this command. Okay, now I can do a Docker build, and let's name this CS2304 intro. And when I build this, we'll see it run all the commands and everything. And again, well, I'm not going to go into crazy depths on how to build and optimize our builds and all that kind of stuff, because that's an entire course that we can dedicate to that. But again, I'm just kind of showing the idea that I can run this here. Let's kill our other node script over there. Now I can do a Docker run, and I'm going to run this in the background and expose the port 3000 from the container image onto my machine. Again, we're not going to get too much into that right now, but run the 2304 intro. Okay. And so that's going to start up the node process and everything inside of a container. And if I curl localhost 3000, let's go verbose, I still get the message hello. Cool. All right, so what I'm going to do now is I'm actually going to tag this image, so CS2304 intro, and I'm going to tag it into my personal namespace. So what this is doing is allowing me to push this image to Docker Hub. which is a registry that allows me to share container images. Okay. Whoops, I guess I need to log in. Let's do that real quick. And I thought I was already logged in. That's okay. 1 second. All right, I just got to get my credentials here. Oops. And then I get my two-factor because I've got my Docker Hub two-factored. Okay. I just did that in another window there, so no worries. Okay, so now when I push this, all right, it's going to push my container image. And so what I'm going to do now is I'm going to go to a brand new machine that has never, doesn't have Node install or Yarn or any of these other things. And the app that I'm going to use is an app called Play with Docker. So it's available at play-with-docker.com. And you just log in. And then when I click start, it'll give me a web interface here that when I click new instance, will give me an interface here. And so what I'm going to do now is I'm going to do that same command. So Docker run it in the background, expose port 3000, Mike37 CS2304 intro. And this is going to say, hey, I've never seen that container image before, so let me download it. Let me start it up and everything. And now when I open port 3000 here, I get my little JSON object message, hello. Okay. And this is a machine that if I try to run Node, it says, I don't know what Node is. I don't know what Yarn is. But yet it's running a container. Again, so I was able to package up this application and into a standardized format, just again, kind of that shipping container, pack everything that needs to run this app. So in this case, it was Node, my source code, the Node dependency, so that Express framework, and it packaged everything up in this container, and I'm able to ship it to a registry where then here on this web browser that's giving me a shell to a remote instance, I can launch this container, and that's all I have to do. And that's really the power that comes along with containers, that I can package up these applications in a standardized way and then move them around. Okay, so that's your quick little demo. And so what we're gonna do for this week's hands-on is, if you don't have Docker Desktop set up yet, we'll get it installed and set up, and you're going to build your own little container image. Again, it's not going to be anything crazy or super fantastic or whatnot, but we're going to just build a simple app, and then we're going to push that image to Docker Hub, and then you're going to run it on a machine instance just like this with Play with Docker, and we'll start there. Now, when next week we're going to start talking about Kubernetes and everything. Pretty much for the rest of this class, we're not going to really be building container images. You're going to be using images that I've already created, because for the most part, Kubernetes is not a framework that you use to build your images. You can run your CI pipelines and that kind of stuff there. But for the most part, Kubernetes is going to be running containers that were already built somewhere else. Okay. And so we're going to basically start at that point of, there's a container image that I want to run, I want to use. And how do I use that in Kubernetes? How do I configure that container? How do I make sure it's healthy? How do I get network traffic to it? How do I, do HTTP routing? All the other stuff around running my apps. And that's where Kubernetes really fits in. So again, we're just going to do a very simple build just to get your feet wet with it a little bit, and then we'll go from there. So hope you enjoy the hands-on for this week, and build your first container image if you haven't already. And as always, if you've got questions, feel free to reach out to me, and we'll go from there. Awesome. Thank you.